Welcome to the Alphalist podcast. I am your host, Toby. Alphalist is a closed community with over 400 CTOs who share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insights into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, please visit alphalist.com to find out more on how to apply. Thanks a lot to my friends at Sastrify for sponsoring this episode. A lot of CTOs I know are responsible for procurement of software as a service by accident and never have the time and energy to work on optimizing their costs. For example, at my company OMR, we have a lot of tools. G Suite, Adobe Creative Cloud, New Relic, and many, many more. Sastrify helps companies like ours to optimize the costs and negotiate with suppliers of such software. In our case, they helped us to save around 20k per year, which is a lot if you look at our company size of around 150 people. It is a simple and hassle-free process we went through, and I can just recommend anyone listening to do the same. They actually promise to save more money than they cost. They are already working with a lot of Alphalist members, such as Runtastic, Westwing, or Emma. To get started using their services, please visit sastrify.com/alphalist. Just check the show notes to get the link. You'll get a 50% discount for the first 3 months in addition. Welcome to the Alphalist podcast. I am your host, Toby, and my topic for today is AI and machine learning in 2021. And my guest today is Rasmus, and he's the founder of Merantix, a Berlin-based AI company builder. And he's basically one of the key people who is pushing for a large AI ecosystem in Germany. So one could call him the AI Oracle. As a co-founder of the German Federal Association for AI, he helps to educate people in politics and really push the scene. Rasmus, can you tell us a bit more about your idea?
Sure. Yeah. Thank you for the introduction and the invitation to the podcast. Very excited to be here. My main job is Merantix. We're a venture studio building AI first companies. So the way it works is we have very talented founders in residence with us. They work with us for 6 to 12 months. We test and validate a lot of business cases, both commercially and technically. And when there's something we're excited about, then we incubate that as a company and also fund it as an investor. And yeah, we've been building a few AI companies in the last couple of years and very excited also about what we plan to build in the next couple of years.
And you just said that you also have an AI campus with, 500 people working there?
Yeah, exactly. This idea started actually just before COVID. We always had all our companies co-located because we believe that there's a lot of value in this exchange of, learning from each other, helping each other. And that's the easiest when you use the same coffee machine. And so we said, okay, look, if we anyways have to look for a new office, why don't we make this a bit larger and also bring other companies that work on AI to the same spot? And so that's when the AI campus idea was born. And yeah, fast forward. In April, we opened it up. It's already like 3 quarters occupied at this point. So despite COVID, a lot of interest in moving on a campus. And yeah, it's a very cool space. And there's already a lot of like collaborations getting started, business being generated on the campus. And yeah, it's also just a really nice place to work from.
And you just said that it's not really commercially driven, right?
Yeah, it's a not-for-profit project. So we've been just like renting the whole space for the next 10 years, and then we're just subletting it at cost. And so when it's basically nearly fully occupied, then it's covering the cost. So yeah, I think the business value comes, I guess, more from then the interactions between the companies.
Okay, cool. I think it's a really great idea. And still, we have to move a little back in time, and you have to tell me a bit more about you as like being a nerd and becoming a nerd. So how did that go for you? How did you step into AI? I mean, it's kind of a very new topic. Like if you look at the latest hype, how did you get into that?
Yeah, sure. So I think it actually started probably in like 7th grade. I was put into like a mathematical science like school class, and there we were actually forced to like take part in a science competition once a year. So we had to do Jugendforscht. It's like, it's a science competition where you have to hand in a project and then it gets graded and you can go on like local and up to national level. And I didn't really like it in the beginning, but at some point I got somehow very excited about, because I realized I can just like build my own projects there and, invent stuff. And so I ended up building an autonomous guitar tuner that tunes your guitar. I built some cleaning robots that would clean your apartment. I developed an operating system for mobile robots. So built couple of projects, and it was always around, I guess, building smart systems, and also at that point involving a lot of hardware. And that just really fascinated me to somehow program something that is intelligent. And so that's how I got excited about it. And then basically studied computer science, did a PhD in computer vision and deep learning. So went quite deep, up to the point where I was like, okay, now I'm like too much in the woods, in the details. I'm not excited about writing another paper and improving like a certain metric for like 1% or so. So then I said, okay, look, like maybe there's other ways to build machine learning applications and have an impact. And so that's when the idea of Merantix was born.
And then you started straight away with that. One more personal question. So still any smart devices at home that you made more intelligent than they were before, or?
So I'm definitely very much into smart home. I haven't like built anything myself. So I should actually do that. I was always like very excited to get like a Raspberry Pi and like play around with it. I think right now I just don't have enough time for this. But yeah, it would be fun. But I'm very much into like, like the heating at home that turns on and off, and like the lightning's being smart, and like, yeah, that's definitely exciting me.
So there's always the problem with the wife acceptance factor with smart home stuff, right?
Yeah, I agree with you. But like, if it works really well, then I think the acceptance factor is not that high. So you just need to make sure everything functions all the time, and then everybody's happy.
So how did machine learning and AI developed during your time with it? I think like it was a huge push. How do you see it personally?
Yeah, I mean, I think it developed a lot. So when I programmed my first neural network, I must have been like 12 or 13. I had to like implement everything myself. So I wrote like every single mathematical operation, every single equation by myself, and it didn't really work that well, and could also really only solve very simple tasks. And then during my PhD in like 2013 to 16, things really started to work. So there was like a big breakthrough in like 2011 when the first like computer vision applications started to work, and neural networks were actually surpassing state-of-the-art results for image classification. And then the time 2013 to 16 was kind of the time where people then started to bring it in all sorts of applications within computer vision, whether it's my research was a lot on like face recognition, for example, but people also brought it into object detection. People also brought it outside of computer vision into language processing. And so I would say 2013 to 16 was a time where, on a lot of tasks, these algorithms were surpassing also human performance. So for example, in age estimation, which was one of the areas where I published a couple of papers, where the task is to estimate the age of a person based on a photo. Suddenly the algorithms were better than if a human would look at the same image. And then it starts to become very interesting commercially, right? Like, because if you want to sell a product and the algorithm is worse than a human, like nobody cares in many applications. But once you say, hey, look, like this is actually better than if a human would do this task, and people get excited. And so I think that was an interesting time. And then, since then, computer vision has been improving further, but by now it's just working very, very well. And so for any task where you have an image, you need to find something in the image, understand what's going on. It's much better already as a human for 95% of the tasks, I would say. And so that opens like a ton of applications. Now, if you look at like other areas of AI, maybe like in the language processing space, there we've seen the breakthroughs more in the last like 2 years or so. So that has been more recently.
With GPT-3 and like the model that OpenAI just published, right?
Yeah, exactly. So that's one of the models. Also, I just heard that a couple of days ago, actually, some researchers in China published a model that is 10 times larger than GPT-3. So there's been like a lot of advancements in language processing. I think the key concept there is that previously you always had to train your language model on the specific task. So say you want to, I don't know, understand a certain type of document or classify reviews. You had to take the neural network, train it on your specific problem, and then it would only be able to solve that problem. And that's the old paradigm. And the new paradigm is you basically just take a lot of text from the internet. Basically, you crawl the entire internet, all the text that's out there, and train the neural network on that. And then that neural network is so powerful that you can apply it for very different tasks. So you could use it to classify your reviews. You could also use it to write a speech. You could also use it to write a financial report or understand a financial report. And even though you've never trained for that specific task, then that's very powerful. And so now people are creating basically these very big generic AI models, making them bigger and bigger and bigger. And then you can just use it for anything you want. And it's surprising how well this worked. I was actually giving a talk last week at a Fortune 500 company, and I took their AGM speech, and like, firstly, like made a version out of it that a second grader could understand. Then I also took some headlines and generated a new AGM speech, which like was actually very good. And I also asked the algorithm to write a summary of it. And yeah, it's nearly pixel perfect. It's surprising how somehow smart these models are these days.
Okay, and if you want to play with GPT-3, is it already publicly available, or is it still invite only and somehow not really accessible?
Yeah, there's some restricted access there, but there are also other language models. So this is just one of them. If you want to take the older version or some of the open source versions of it, there's some alternatives. And people are working on more and more of those. It's very expensive to train them. So you might invest like a few million euros to train it once, because you need so much compute power to run it. That's why it's not like being like that, there are thousands of versions out there, but certainly a few. And people also in Europe, actually, and that's also something we push with the German AI Association, are trying to push for a European version of the model that is freely accessible for everyone.
Okay, because OpenAI sounds very open, but also has commercial thoughts behind it, right?
Yeah, exactly. I think they've been more open in the past, but Microsoft is now getting involved there and investing a lot of money in them. And so now they're getting more and more commercial and becoming more and more part of Microsoft, which changes a bit the way they're positioning themselves.
Okay. And are there any other examples? I mean, image classification is obviously something you can easily also try yourself. I mean, in the public clouds, there are typically like services you can use to predict age and stuff like that, or if there are any nude parts in the image or something like that. And then there's GPT-3 and language processing. What about other applications? So, for example, predicting time series data or results on the stock market, for example. Is there any progress, or is that still a bit bumpy?
That's an interesting question. I think the thing is, when you have time series data or tabular data, you can think about it as like a spreadsheet of data where you want to predict something, some column. People still use like very traditional methods, regressions or support vector machines to make those predictions. More recently, there have been some papers where you actually also use neural networks to do the prediction, because like in the past, they weren't like much better on this than any simple algorithm. But there's been like some progress in the last 1 or 2 years, and people try to now use these neural networks, and it's slightly better. But also the thing with tabular data is the data is very low dimensional, right? Like if you have, I don't know, like the last, if you take your stock price example, if you take the closing price of the stock market from the last 10 days, it's 10 numbers. And sure, you can on those 10 numbers try to predict what the stock price is going to be tomorrow, but there's only so much in those 10 numbers that even with the most crazy model, you won't create the oracle of the stock market. Like you will need much more data. And so that's why usually the constraint is then more on the data side than on the model side for tabular data. Some other areas where I'm very excited about machine learning is the space of biology. So like biology is being like traditionally a very experiment heavy kind of space where people are in lab coats, are in a lab, run like experiments, with pipettes, like just like your high school like chemistry lab. And that has been changing quite a lot in the last 2-3 years. So firstly through lab automation, so basically building labs that just run experiments at scale and also do that more cheaply. Especially also because the DNA sequencing costs have been going down a lot, even faster than Moore's law. So you can now basically run much more experiments through robots and also sequence the DNA of, for example, proteins. And then you can actually use machine learning to analyze those. And we have actually also one company working in that space. And so the way you can imagine it is that you sequence a protein. So you get this like long list of like letters. It's a bit like text, like in natural language processing. And then you use like similar techniques to say, look, like this is not English as a language. This is like a DNA sequence. Let's try to predict how this protein might behave. And then you try to predict it. And if you like the behavior, then you run the experiment in the lab and see if it actually behaves that way. And then you iterate it over and again. And so that's a really cool application where somehow you have like physical experiments, robots, NLP models, and bring that all together. So yeah, I'm personally very excited about biology overall. There are like tons of applications. And we saw that now with COVID, right? Like in the pharma space, there's it's very interesting applications for vaccines or general like treatments, but also in the biomaterials, like creating new materials. I think that would be also very cool.
And do you know if, for example, in mRNA development, there has been any AI adoption or application?
Yeah, no, for sure. I mean, they're also sequencing the RNA, and then based on that, they're basically then also trying to predict what kind of experiments they should run so that they optimize them in the right way. And you also use that when you, for example, want to see how certain compounds act on certain targets, and the shape of the target in the human body, where your compound should like bind to. You can like obviously try that out on like mice or humans, which is takes time. It's like costly. There's a lot of other factors, or you can basically just like simulate it or predict it, and so then you can basically run much more targeted experiments, and it's much more likely that they're successful because basically the option space is so large. There's so many different things you could try out. In the past, people have just like more randomly kind of run experiments, and with better targeting, you will be much quicker, much more successful.
Okay, so you think that also helped in the development speed in the last year?
For sure, yeah.
Okay, cool. And what about like classical medicine experiments or like simple things? Simple, I don't know how simple it is, like detecting skin cancer. That's like one of the most known, and obviously, I guess there are like 1,000 companies that do that using AI. Is that something that is already solved, or is it still all experimental? Is that still?
I would say from a technical perspective, it's close to solved, or I would say it's probably solved. Like the thing is, building a simple skin cancer algorithm is a matter of a couple of hours, right? Like you download a data set, you run your standard algorithm, it will perform pretty decently. Now, if you want to make it robust as a medical product, make sure that it can work with different lighting conditions, different skin types, that it doesn't make anything stupid, predict anything stupid when you show something that is not skin. Like making that robust algorithm is a bit more work and much more work actually, but you can also do it. I think the bottleneck is often then less on the machine learning side, but more on the commercial product side. Like, assuming you have built this algorithm, and it's even certified as a medical product, like who do you sell it to? And how can you make sure that it quickly gets adoption? Do you build a direct to consumer brand? Then you need to acquire customers. Or do you try to collaborate with doctors? Then you need to somehow convince them that it's a good idea to use your algorithm and make sure that they're not scared of being replaced, and that it also fits in their workflow because they already have like 10 existing softwares that are built in like 1993. And so there is, a lot of like legacy IT infrastructure you need to integrate with. Then each country is different. So like all these things are I would say like 90% of the work, and of the algorithm, which is, as a researcher, I wish it was the other way around, but that's unfortunately the reality in many areas of AI.
So you have to start at the university and convince doctors straight away and get them started using AI like during their medicine studies, right?
Yeah, I think that's a great idea. I mean, like there's this I think there's a startup Amboss that helps you to practice for your medical exams, and they also actually went to market through the students, and I think now they're also being used a lot in hospitals because people got so used to it during their studies. And I think you could actually do something similar for this, that you somehow integrate that into the university courses, and then people can, like, I don't know, get used to it there and realize it's a much better solution. The challenge you have to solve is like that a lot of the doctors out there are actually, like the older generation. The ones who run the big centers are not 26; they're usually like 50 or so. So there's a lot of education you have to do so that they're not scared. But once they use it, they love it. That's the interesting part. So once you get them to use it, they're like, oh wow, this saves me time. I'm not as scared anymore that I make mistakes. I can make more money. The algorithms find stuff that I would have missed. And so we actually, for example, one of our medical imaging companies found a couple of cancers that doctors would have missed. And that's great, right? Like you're actually like saving lives. So you need those success moments, and then they start trusting the algorithms. It's a bit like when you have a new employee, in the beginning, you also kind of double check every little step, wanting to make sure that the person does everything correct and kind of seeing what they can do well and what they can't do well. And in the end, you have a similar process when you have deploy an AI. People are very skeptical at the beginning, they check everything, and then at some point they start trusting more and more and realize, oh wow, this actually works really well. And so that's at least like my mental model, how to get things in the real world.
Yeah, I think people have to see it as somehow like a self-extension, right? Like just becoming the better self using machine learning and AI. But rarely people do that because they feel that it's somehow attacking their job, right?
Yeah. Yeah, they're scared, right? They're scared that they're being replaced. But the truth is, especially in many of these critical AI applications, like in healthcare, it's not about replacing, it's about augmenting. It's about making sure you make less mistakes, making sure you're quicker, making sure it's more cost efficient. And it's not like we replace it. It's not even legally allowed by law. Like there's the Arztvorbehalt, which is, one of these very big like laws, at least in Germany, which basically says that it needs to be doctor who makes the final decision. And that's kind of at the core of our whole like medical law here. So it's hard to change that. It's kind of the Grundgesetz of medicine.
This episode is kindly supported by Fastly, the biggest challenger in the CDN market. Fastly is pushing ahead the technical boundaries and is, from my perspective, the best solution on the market. Fastly is known as one of the key drivers of the Edge Cloud movement. Well-known customers of Fastly are Shopify, the New York Times, Reddit, GitHub, and many, many more. If you want to try it all with first-class support, just go to fastly.com/alphalist. But still, I mean, laws get changed every once in a while. And if you let's pick another example. Let's pick cars and taxis. So if you look at smart cars today, or even Teslas, then you have that full self-driving and it's still behaving stupidly. It's in a way an augmentation, right? It's somehow built into your driving process and your driving experience. And at a certain time, I'm quite convinced that it will be that good. I mean, if you listen to Elon Musk, then it will be this year. Like at the end of this year, my car will drive on its own and earn money for me. Even if it's not, it will develop, right? And it will potentially let the taxi driver disappear at a certain time.
Yeah, no, I think it will happen at some point, and it will be like a gradual process. It will not be from like one day to the other, but yeah, probably in like 10 years, in like many cities or countryside, cars will drive autonomously. I'm very convinced by that. Because in the end, like, what do? We sit in a car, we look out there, we have two eyes, we see what's going on, we process it, then we take a decision, we steer left or right, we brake, we accelerate. I mean, it's somewhat complex, but also somehow like very easy, right? Like you just need to make sure you kind of stay on the street, you don't drive into something, you kind of check where the other cars are going. Like we learned driving in like, I don't know, I think I took my driving test after like 30 hours of driving. Like it's not that much. And now if you dump like millions of hours of driving into an algorithm, that's a much safer driver than actually I am, because that has seen so much more like weird corner cases, like which I've never seen when they put me in the street. So it's probably much more safe to do this. And that's also like a big area of like AI development right now, kind of reducing the amount of training data you need so that the algorithm gets intelligent. Because right now we're still dumping like, a ton of data into the algorithm, much more than any human would need. And it's somehow not sensible. If a human can learn it in 30 hours, why should not an algorithm also learn it after seeing only 30 hours of driving? And there's still a big gap, but we're reducing it every year. And people start to build algorithms that can learn from much less data and get the same performance.
That means that one of the key advantages of Tesla, that they have so many training material, get less and less worthy over the time, or?
Yeah, I think like this whole like paradigm of data is the new oil, I completely disagree with. It's like this like sentence like many people say because it sounds smart, and when people say, look, like we have data and that's why we're such a valuable company, and I think it's complete bullshit, because sure, it's a head start. Like we've probably built the largest data set in medical imaging and breast cancer screening. Sure, that's great for the company. It's a great asset, but like, to be honest, like others could build the same asset as well. It's just a matter of like money and time, and then you get there as well. And that advantage, as you said, like coming back to what I said previously, is getting smaller and smaller, because you can get to the same algorithmic performance today with much less data than like 5 years ago. And that trend will continue, right? Because the algorithms will get better. So you need even less data. And people also start to work also with less labeled data now. There's a lot of interesting progress there. So that also will just, diminish the advantage of these data sets. But yeah, still currently Tesla has a lot of data, is collecting that nicely, is working with that nicely. And that's a huge competitive advantage still towards the classical car manufacturers. And it's also less on I think for cars specifically, like one part is training the algorithm. The other part is also testing the algorithm. And there certainly it helps when you have a lot of data, because even if you now can train it on less data, you can then still run it through like 10 million of past hours of past driving and kind of make sure that it never did something stupid. And that's a great way to ensure that whatever you deploy is safe, because it's in the end always, and Tesla had a few of those, right? It's in the end always about like single accidents where something very stupid happened that ultimately could create a huge backlash. And so you need to be very careful, even just from a commercial point.
But there's always the stupidity of human involved, which is unpredictable, right?
People try to predict it. People put cars in the cameras in the cars and try to figure out, like, do people do something stupid? And if they, don't sit on the seat, or if they, get super drunk, or like these things you can detect. You just need to make basic build a stupidity detector. But I guess like you then have like 10 class labels of like, okay, is the person drunk? Is the person in the right seat? Do they have their eyes closed? I don't know, like whatever. And then there's probably still like 5 more stupid things you could have never imagined somebody doing. Somebody suddenly sitting on the roof, or, whatever, putting a dog there. So yeah, humankind is still very creative there, I think.
I think Tesla already has it, like partly at least, right? I think they predict how the driver is behaving and so on, and have a camera inside. And
yeah, and I think also some of the traditional car manufacturers even do it when they check whether you're still like focused on the street. There's also some applications.
Okay, do you think like that Germany can still catch up in that space?
I'm an optimist, so I hope so. Yes. It's challenging. Yeah, it's very challenging. I think it's just a mindset, right? Like these German car manufacturers, they come from like, we outsource everything to our suppliers, and we just like squeeze them very hard with our procurement, and then we assemble everything together, and then we have a great brand. And now it's about like building a software company that is structured very different, that has very different development cycles, much more agile, big focus on data and machine learning, and that's a very different mindset. And so now you need to reorg these companies, and Volkswagen, for example, with their new software org, are trying this by basically creating completely new units that are outside of the main business, so that they can get that culture and also attract that talent.
Yeah, talent. Getting talent is something hard these days, right? But I think on that end we're kind of on a good path in Germany, that we at least have a good education system and so on, right?
Yeah, no, we have. I mean, in terms of machine learning research and academia, we're on the same level as all the big schools and companies in the US. We have great talent. We have some great machine learning professors. Like everything that is happening, for example, in the Cyber Valley around Max Planck in Tübingen is great. There's a lot in Munich, around TU Munich. Here in Berlin, we have the TU Berlin and Bifold, the new research center they're building. So there's a few great spots with great researchers. The challenge is that many of those, especially the students, then also leave Germany, right, or join some big US tech companies, and so we need to create more opportunities for them here locally. But it's good. I think, especially also Berlin, it's so English speaking by now. Immigration is much easier than the US, and so I think it's been getting better and better, and people love moving here, and so I think we can kind of bring the critical mass of AI talent here, not just from Germany, but also from outside. And yeah, there's a lot of people who want to return also from the US, right? Lots of great researchers who are from Europe originally that now with, everything what is happening in the US are hey, would love to come back. It's just very hard to find a job that is comparable to what I've been doing in the Valley before.
Okay, and there we come to your elevator pitch, but maybe we go one step back to trends. You mentioned machine learning ops, ML ops as one of the trends that you currently see, and I can somehow feel that there's a need of building simple tech to essentially go from the initial test to the really deployed model. What do you see there as tools and trends available on the market, and how quickly do the clouds progress, for example?
Yeah, no, sure. I think this is a huge topic, because also even when I look back within the Merantix times, 4 years ago, so we would write, we would build everything ourselves, every model we would define ourselves in TensorFlow. We would build our own system that would help us to configure experiments, and basically when we train a machine learning model, make sure that 6 months later we can reproduce it and know what was happened, what data was used, what algorithm was used, what machines were used, what was the result, so that also if a different employee tries to reproduce it, it works. And for that, we had to build our own systems. And so we had not only to maintain our machine learning models, but we had also to maintain our software around that basically maintains the models. And that's a lot of parts you then have to build yourself. And I think in the last couple of years, people realized, it's actually independent whether you're in breast cancer or autonomous driving. A lot of these challenges are the same. It's about it's about scalability. How can you basically easily train something on one machine versus on 1,000 machines? How can you deploy to Google Cloud or to AWS and make that seamless? Also run stuff locally. How can you make stuff reproducible? How can you maintain your machine learning models in production? If you deploy a model and suddenly you realize it starts to predict something stupid because something has changed in the real world, the data you get in, or a sensor broke, that you realize that quickly. So there's a lot of these parts that are always the same, independently of what your specific problem is. And so many companies saw that as an opportunity now to build these so-called MLOps tools that kind of help you do this automatically. And so certainly the big cloud providers, for example, AWS with SageMaker, are heavily pushing to provide that already on the cloud, so that when you go on AWS, you not only can buy compute, but you can already get access to an API that can do standard image classification, that can do standard text processing. Even for biotech, for example, there's some stuff on the big cloud providers. So they're trying to move more and more up the stack. And that way also lock you even more in, right? Because if you just use compute on AWS, it's very easy to switch to GCP. Now, if you use also all their software on top, it gets harder and harder. More convenient stay, and that's where they make a lot of money. And I think from our side, we're pretty cloud provider independent. We actually have stuff on all the big cloud providers, and we can also like easily switch. We use Kubernetes just to like, scale and orchestrate our clusters and make that easy accessible. And then on the MLOps side, we've been using Seldon, which is a MLOps framework that builds on top of Kubernetes and basically helps us to handle the entire ML lifecycle of these models. So both from training as well as from deployment.
And what if you had like a team with, let's say, less than 20 employees? I mean, just as being a startup, where would you start? Would you always use Kubernetes and that tool chain, or would you potentially also go with something which has more lock-in? And which cloud provider would you pick, or would you pick something independent? Is there anything you can anything you can recommend for younger companies?
Yeah, I think that's a good question. Kubernetes, we also only started using maybe like 1.5 years ago. So in the early days, you would also just spin up machines individually, and that was super easy because Kubernetes comes with some overhead in maintaining a Kubernetes cluster.
And the learning curve, yeah.
And there's a learning curve, and so you need a certain size. You need, in the end, like 1 or 2 people that are somewhat responsible for maintaining this and making sure everybody knows how to use it. So I wouldn't recommend that for your first couple of employees. Generally, I think if it depends what you want to do. If you want to do a lot of prediction that are relatively low value, you need to be careful in using the cloud providers because you might end up paying a ton for these predictions. But if your predictions are relatively high value, so if you you pay say like a cent on Google for a prediction for the API, and you can charge like €2, then it's probably totally fine to use their services. If you make only 3 cents and you pay a cent, then you should probably from day one think about like setting up your own prediction model. So I would look at this from a like very economic argument and then make a decision. But still, to prototype stuff, you can just use stuff out of the box, and just run it out from the cloud providers, or just use some open source, right? Like you could also just use some open source. Like you rarely need to reinvent the wheel here.
But then you all have the total cost of ownership again, and so on. If you use open source, so is then like Google Cloud or AWS? Does it move the needle? Is there like a large difference between them?
AWS has still like much more adoption, like more broadly speaking. So you realize that the products are a bit more mature, maybe. But also there's a bit more legacy. Whereas like Google, like I think a lot of the things they started a bit later, so they just thought them from scratch. And especially when GCP started to take off, they immediately focused on a lot of ML features in the cloud, whereas like AWS came a bit later there. But we use both. I would say we have not a strong preference. We've been also using Azure because for especially when it's towards corporates, they often already use Azure. Like they have a bit more adoption there. So from a business perspective, sometimes that is a good idea. We are pretty agnostic, and we also try to stay agnostic. I mean, this is in the end also what Gaia X, the big European project on the European cloud is pushing, that you somewhere don't get logged in with one of the vendors and you could still switch, even though you might not end up switching because it's still like an overhead, that you always keep that in mind that you can still, because you never know what happens. And when you scale, things might get super expensive. So it gives you also leverage towards the cloud provider.
Okay, cool. Thanks a lot. So could you tell us a bit more about Merantix and the startups that you invented or came up with?
Sure. Yeah. So we've started 4 product companies so far. So the first one is Vara. They're a company in the breast cancer diagnostic space. So helping basically doctors in breast cancer screening to make less mistakes. Right now, actually 25% of the cancers that could have been seen are missed. So there's a lot to improve. They're in the market by now with a medical product, already running in probably more than 10% of the screening centers in Germany and also in some other European countries. So there we really went from building an algorithm, certifying it, putting into a workflow solution for doctors and getting that on the market. Now we are actually very much focused on getting in as many screening centers live as possible. So that's the first company. Then with Zia Search, they're a data management company in the autonomous driving space. So kind of what we talked about before, that basically in autonomous driving, you manage petabytes of data from cars. And it's not like you can easily look through that anymore and work with that. It's a bit like when you go on a holiday and you take like 100,000 photos, like it's a pain to like sort them and figure out what are actually the 10 relevant ones you want to print out and send to your grandma. And so it's a similar kind of platform, but for autonomous driving data. So you know what to keep, what to throw away, where are some interesting things happening. You can easily pull data out of with certain characteristics so you can improve or test your algorithms. And then more recently, we started 2 companies, Cambrium in the synthetic biology space. So they're optimizing proteins and focusing on the bioeconomy. So not pharma, but basically the first use case is cosmetics, actually. So we are producing a bio-based collagen that is used in cosmetics and has very good properties. And so, yeah, we're right now actually setting up our automated lab right outside of Berlin. And yeah, there will be like robots running the experiments, and then we use the data to optimize the proteins. And then we have Causa. They're in the space of business intelligence. So there we actually work with tabular data. The thing is, the idea is that now that many companies have like pretty good data warehouses and all their business data like relatively good, well stored, especially like scale ups. You can now view the data. You can use like Tableau or so and look at it, but the analytics step of understanding what is really going on is still done by a human. So, for example, I don't know, like some KPI goes down. I don't know, the average basket size in an e-commerce store. The manager would go to the business analyst and be like, "Hey, look, explain why this has happened," right? And then you go there and you're like, "Okay, what has changed over time? Are there certain segments that have changed? Are there certain like weird outliers in the data?" And the idea is that the analysis is always the same there. It's always conceptually the same. And so we're basically trying to build a platform that is automating this business analyst so that the manager can just say, "Look, I care about this KPI." And then the algorithm will automatically tell you, "Hey, here are 5 reasons why this could have happened." And then you can work with that. And yeah, they just actually launched their public beta last week. So you should try it out. It's pretty cool. It's pretty fascinating. And then lastly, there's one company that's, all these 4 first product companies I just mentioned, they're all, venture funded. We've invested, you can invest up to 3 million euros in those companies with our fund. Also majority owned by the team. And then we have one other company, Merantix Labs, that is a bit different. That's 100% daughter of Merantix. That is our consulting solutions provider. So there we build customized machine learning solutions, sometimes for Fortune 500 companies, sometimes for startups, SMEs, pretty industry agnostic. That itself is a very growing, almost profitable business, but it's also informing a bit our venture building, because if 3-4 customers are all having the same problem, maybe there's an opportunity to not just build it 4 times the same time, like do 4 projects, but rather say, look, let's build a product and sell it to them, and it's cheaper and better for the customers as well. So there's a lot of like synergies between kind of Merantix Labs and the venture building part.
Okay, interesting. I like the log analysis or BI company. I just ran across like a use case where I was just looking at stack driver logs in the Google Cloud and just saw like something that like a pattern that happens every few seconds, and that I expect the cloud providers to have something comparable in a few years, where you actually which actually helps you to repair your stuff, to get your business optimized and so on. I think like even at a certain time, they can hopefully like pretty much help you with your business, right?
Yeah, it will happen, right? Because like 10 years ago or 15 years ago, we also already used, or even 5 years ago, we already used a lot of software, but much less tools than now. And also those tools will generate much less data. And now you have all these different tools in your stack that generate data all the time. And there's no way like a human can look at all this and understand what's going on. And, maybe I know about like a certain tool, but then there's another engineer who knows about another tool. And so the knowledge is also very siloed in the organization. And sometimes you need to pull data from a few different tools to understand what is the real problem. And so we just believe, it shouldn't be humans doing that. There should be a machine that is constantly looking at the data and giving you these insights.
Okay. So that was very nice so far. I'd like it to also that we oriented the podcast around like practical application of AI, and you gave so good examples. if I would ask you for 3 recommendations for CTOs that just wanna get it up and running. I mean, it's a very generic question, I know. But what would be your recommendation if I just want to play, for example, with language models? What would you recommend me?
Yeah, I think first of all, Selden is great. So if you need an MLOps platform, I would highly recommend them. We are super happy with them. Secondly, Hugging Face this is like a model library where you can use like a lot of machine learning models that you can easily try out. So that's very easy, and it's worth checking out. And then I think the third thing, just continue reading papers, sign up for like newsletters, and see what happens at the big machine learning conferences. Follow your favorite researchers, because the field is still moving very quick, and it's very easy to miss a trend. And so even though right now like a lot I have to deal with is like business and hiring and fundraising, I still try to find at least like an hour a week or two where I just kind of check out what's happening in latest research. Because if you don't do that for like a year or two, you can easily fall behind and then invest in the wrong technology.
And what would be the conferences to look at?
So the biggest one is NeurIPS. It's the big neural network conference. It happens once a year, usually towards the end of the year. That's generic machine learning, so it's language and computer vision, and also more classical machine learning. And then for computer vision specifically, there's CVPR that usually happens around the summer. That's all computer vision.
Okay, and anything in Germany?
Not sure. I think we usually go to the international ones, and I mean also all the German research is published there. It's
Okay.
not. It's relatively uncommon for these conferences to be regional. I mean, they're usually global because the community is so global. So you have people from Europe, US, Asia coming there. I think it's good to be there. I mean, there are some local smaller conferences, but that's maybe just to meet some local people. The research really happens at the big conferences.
But it's then very research focused. Is there anything application focused?
Yeah, it's actually, it has shifted. So these conferences have been traditionally very research focused. But more recently, firstly, the big tech companies started to publish a lot there. So it's anyways not just universities anymore, but also Google, DeepMind, Microsoft and so on publishing there. And secondly, you have also a lot of startups there who at the end want to try to recruit there or present their products, maybe because also if you have an MLOps product, right, it's a great place to basically sell your products to machine learning researchers and practitioners also from large companies. So the audience has very much shifted from 90% researchers and 10% from companies to probably 30% researchers from universities and 70% from companies. So there are still, basically, long story short, there's still the right place to go to also when you're a company.
Okay. So I now got a little surprise for you, Rasmus. And I just looked up on GitHub and found like a secret and unreleased experimental version of TensorFlow that came with a time machine library included that does not only predict but also allows you to travel back in time. And I wrote like a little Python script which allows us to travel back in the early days when you got started with in product management at Google. I think it was in 2012. And we can now watch yourself for a second. You're writing some code, I guess, and observe you. And you now have the chance to actually manipulate time and whisper something into young Rasmus' ears. What would it be?
Yeah, that's a great question. I think I would have used deep learning earlier in my PhD. So the first 1.5 years, I was actually using more classical machine learning, and everybody in my lab was super skeptical about deep learning. And I was then, okay, I guess they're right, because everybody was like, oh, well, this new thing, I'm not sure if it's going to work. And it took me 1.5 years or so to then say, look, I'm just going to try it out. And then, immediately it was clear it works so well. So I think if I would have known that earlier, I would have probably, had one less year of quite painful PhD experience.
Okay, so your recommendation would be to dump scikit-learn and start with deep learning straight away.
Yeah, exactly. Yeah.
Okay, so Rasmus, thanks a lot for the podcast. It was very helpful to understand where we are these days. Next time we potentially talk about politics a bit more, because you're also like deeply involved in KI Bundesverband and do a lot there. So that's what we potentially do next time. But I like it to be very much practical and application heavy. Thanks a lot, Rasmus, and hope to see you again soon.
Thanks, Tobias, for the invitation. It was a lot of fun. Thanks.
Thanks.